Hello, and my name is Steve Boyd, and I'm going to give you a quick webinar on how to use the normative.ca website. Let me see if I can switch slides. So the goals of this webinar are to show you how to prepare your data so that it can be analyzed by normative.ca, teach you how to generate the plots and the measurements of percentile as a basis of sex, skeletal site, and HRPQCT scanner generation, and also to show you how to allow your study participants to access their own data or to share their data with them. So the expectations are that you use a Scanco first or second generation HRPQCT system, extreme CT system, that you already at your site have already completed a morphological analysis to measure things like trabecular thickness, etc. So that's all done. And that you know how to edit a file, that you are used to basic editors or at least to use Excel. A little bit of background about Normative. Normative.ca is based on data that's been collected since about 2005, on the first generation system, followed by more recently the second generation system. All this funded by the Canadian Institutes of Health Research. So it's all publicly funded work that we've done, and so I thought it makes most sense to make this available to the community, back to the community, both in Canada and abroad. The website itself was built and is hosted by the Bone Imaging Lab. A summer student at the time, Saeed, built the website, and we've been expanding it since with some support from him. The ongoing costs for the website, hosting, and so on are covered by the lab. Hopefully we can maintain that without having to ask people for fees. Who can use normative.ca? The idea is it can be used for nonprofit research. So you can use it for free. If you do want to use it for something nonprofit, so if you're, for example, doing fee-for-service work where you give an extreme CT scan result to a patient of yours or something like that, and you've charged them for it, then I'd like to know about that, and we can talk about how to make normative available to you as well. But ultimately, we're working on the honor system, and I hope to keep this service available to the community. Any support for it is more than welcome. It's not expensive to run, but it does take time and effort. The databases that are underlying normative come from 3 different publications that are listed here. The first generation was from a publication at JVMR in 2016. The second generation data set was based on extrapolating what a first generation data set would look like, estimating second generation data. And so that was in 2017 at JVMR as well. And then most recently, it's still in press, but the paper with the second generation cohort has been published. So right now we've got 3 options. Quite honestly, you shouldn't be using the XT2 star, the estimated extreme CT2. You should be using the real one, XCT2. But we've kept all 3 there for now for posterity. Could you add more populations? Could we add more populations? Absolutely. We could have an option, for example, for pediatrics or from cohorts I know that are in Hong Kong or Japan or other parts of the world. There's no doubt we could add those. So please contact me if you think that'd be helpful. And, you know, we've put this together and there are going to be small glitches and bugs probably that you're going to discover, or you're going to have ideas of better ways to present the data. I would more than be welcome to hear your suggestions. So please let us know. And if there are bugs, please be patient. It's not trivial sometimes to make these changes to the site. So this was all born from the problem of we scan people, throw them into the extreme CT scanner, we get a results sheet like we're showing here, and we get all these great numbers, but it doesn't give any relevance to what you should be expected. For example, in this case, for the radius of a male who is almost 68 years old. So a number like D100, the density of 342, is that good, bad? It's hard to know. So normative is just designed to give you some relevance to that data by looking at population norms. So we established that. This is an example from one of our normative plots. This is just showing cortical BMD as an example. On the x-axis is age, and on the y-axis is the BMD. And then we show the percentiles that have been fit using a gamless approach, showing the 90th, 75th, 50th in the middle, 25th, and 10th percentile on the bottom across the lifespan. So here's what the website looks like. This is a slide. I'm going to actually try to show you the actual website. So we're going to do a new share to the website itself. And this is what the website would look like when you log into it. So you go to www.normative.ca. And as you can see on the website, there are two options. You can log in and through the researcher portal or through the patient portal. And if you are new to using Normative and you want to start using it, both of these require usernames and passwords. You probably, if you're listening to this, want to use the research portal. And you need to sign up. And in order to sign up, you just click down here. It'll send a request that actually I will receive, and then I can approve, and you'll get notification that you're ready to go. So let's go back to the slides. So I'm just pointing out here that you should click sign up. So before you start using Normative, you're going to have a data set. It's going to look something like this. And in fact, I'm going to change the sharing again, and I'm going to show you that data set. This is how it might come off the scanner. So what you can see here is just like you normally get off the scanner if you use the UPAT list function. For a participant, which we've just coded as bone participant 66, 62, and 53, they're listed there twice because we scanned their radius and their tibia. So same persons, different sites. And then these are all just hidden because it's too much information for the box. It shows in the things like the D100, decomp, cortical thickness, etc. for their first scan. And if you keep scrolling, you can see the results for their second scan. And you keep going again, and you see their third scan. So the first thing that you need to do with Normative is you need to convert this format of the output file into a format that Normative can read. So if we go back to the slides now, this is just basically what I showed you, that slide. And so now we want to convert that to something that makes sense for Normative. And the way Normative needs it is instead of a row that has 3 measurements in it, we need to have 3 rows for that measurement. So I'll show you. So here now for the radius, we've got their first measurement, radius left for person number 66. Then we've got, where's person number 6, their second radius scan here. And then person number 66, their third radius scan here. So those 3 sets used to be in one horizontal line. And then we've changed the columns. And now what's important is we use slightly different headers than what Scanco uses. And these actually, I just showed them on top of each other. You can see wherever Scanco, for example, would call it age 1, we just call it age. The age is different, for example, for this person, bone 66, at their radius at site scan 1, than at scan 3. So there are 59 and 58. So it was done a year later. So the age has changed. So this just has to be updated for the correct age. Then these things like cortical area, we call it cort R. Trabecular area, trab R. D100, we call total BMD. Decomp, we call cortical BMD, etc. Okay? The one parameter that's not in the standard outputs is the estimated failure load from finite element analysis. And so we add that as well. But once you have all of this, you just want to delete these old titles and use these as the titles that are available for Normative. So we had 3 people scanned 3 times at 2 sites. That's 3 times 3 times 2. So we should have 18 rows here. And so that's what we actually have here, 18 data sets. And we're going to figure out normative results for each of those data sets. What you do, I'm actually going to show you the way to convert that, sorry, go back that slide, the way to convert it into this format. I did it manually. I just did it carefully using Excel, and I moved all the files around. Ultimately, it has to be saved as a comma file, CSV file, and so you can do that with Excel. And if you do that, then what it will look like is, so this is what it would look like if it's not in an Excel file. And this is the file that needs to be loaded onto Normative, okay? So it's just the same information, just commas separating the values. And you can see the finite element failure load is the last set of values, etc. If you had a column here that Normative didn't understand, you know, maybe a parameter that we hadn't anticipated or something like that, then Normative will just ignore it. And you'll know that it's been ignored because you won't see any results from it. If there are some parameters that you think are important that are missing and you discover them, let us know. So we're going to go back to the slides, and we now go and log in to your researcher account. So we click on the researcher portal, we enter our username and password, and we get to the dashboard like this. And at this dashboard is this window, which is where you drop that .csv file that I just showed you. If you're not sure about what the format of the CSV file is, you can click here and click on this template CSV file to see an example, and it'll just download one to your computer, and you can then edit it as you need to. So we're going to literally drop that file, drag and drop it into this window, and it will read it. I've dragged and dropped it now, so I can't really show you how I do that, but you just click it off the desktop and drop it onto the web page. And the first thing it'll do is ask you, what kind of data set do you want to analyze? So these are the three choices that we talked about: XCT1, XCT2 star, so that's estimated, and XCT2, which is actually based on true extreme CT2 data set. So once you've selected it, in this case I chose XCT2, then we will start the process. So as I said, the first generation is based on this paper. The second generation estimated is based on this paper. And then the last one is still in press. We don't have that quite yet on PubMed, but that's the second generation data set. I already showed you all that. But so once I've dropped the file into here, it shows up as a little icon that is dropped onto the window. And then after I do that, it'll automatically load up this all the headings that it found in the file. And then what I can do is I can just click on select deselect all, and all of these things will be checked, and I could uncheck some if I really didn't care about them or didn't want them included in the analysis. Once I've done that, I click go. Oh, sorry, you do click go, but I also wanted to show you a few other options here on the dashboard. So you've got, instead of my dashboard, which you just saw, we can see my patients. So this shows all of the people that have been scanned at some point as part of my my account. Then it's got a little utility here. So instead of manually reconfiguring the file so that it is prepared for Normative, you can actually take that IPL output and drag and drop it into this window, and it'll create an appropriate file for using with Normative. I'll show you an example of that in a sec. It also shows you the number of different times that you've run analyses on it, and you can go and find some of those analyses. We were doing some debugging, and that's why we see some script errors here, but those won't matter anymore now. And you can change things like your usernames and password. That's your personal username and password, and then you are in charge of the data that your subjects data, and each of them may have a username and password, and you will be given those automatically when the analysis happens, but you can actually change them as well. So after you've clicked go, I'm back again to the dashboard. It'll ask you, would you like PDF reports and online access for your patients? So if you click yes, and what it'll do is it'll create an individual report for each person that you entered into your file, and it will create a username and login so that they can log into the Normative website remotely and view their files online. So we hit go, and once we hit go, you'll see it spinning. And what it's doing now is the server is actually doing all of the calculations, and it's a bit slow, so be patient. You'll see a spinning wheel for a while until finally you'll see this window change to a download button. And once you've got that download button showing, and in my case, it took about 3 or 4 minutes before it was finished calculating, I click on it and it downloads a file to my directory. So I click that and it downloads a zip file. That zip file I've opened up here, and I'm showing all the different files within the zip directory. In fact, so there's a subdirectory because I said, yes, I do want patient reports, and each of these are individual patient reports for a different person, okay? And then it shows you plots. Remember, we've got radius and tibia, min and woman. So that's 2 by 2. There's 4 different types of plots. And for each one, there's the same parameter, cortical area, cortical area, cortical area, for example, okay? I'll show you an example of one of those plots. Then there's a Readme file that gives you some instructions on how to interpret the data and also how to cite the data if you're using this in a journal publication. And then finally, the actual outputs of percentiles, which can be quite useful if you're looking at trying to make some quantitative measurements. So let's look at some of those. So first, the patient reports. It's a 3-page PDF report. And right now, we show it in terms of these circles, and the colors represent sort of in the medium, like good is green, medium is yellow, and not doing so well is red. So it's a quick color-coded way of looking at your percentiles. To be honest, I don't think the data that I used is actually real data, so these circles aren't going to make a lot of sense. We also show the normative data in terms of these plots here, where you can see where, just look at plots of how people compare on the scale. So it's not really a percentile or anything like that, but it can be useful. And then this is just a generic sheet. These are not individualized to the report. It just shows a generic what a bad, quote unquote, bad bone looks like, what a medium bone looks like, and what a good quality bone looks like, and a few details about the and actually a few plugs as well for our institute. So the README file has information like this. It explains the different databases and the citations, and gives you, if I scroll down, this is a slide so I can't, it tells you how you can actually cite the work in your research. This is an example of one of the many plots. So this one's for total BMD. So there are 5 dots on here. So 5 different measurements that were done. It's just a way of visually seeing your data. For a very small data set like I showed here, it's probably not very useful, but say you're studying type 2 diabetes or something and you've got 100 participants, you could download all of those onto the normative site and it'll plot them all on these where you can see your data relative to the percentile curves. So it can be quite useful. And then this is where the actual data is, the real quote unquote money. I've broken it here in the middle because it continues on. But first part of it is a regurgitation of what you input. So the output has the exact same information as what you input. And then in parallel to it, for every one of these parameters starting at cortical area, it shows the Z-score and the percentile for that person. So you can then, for example, look at the percentile of cortical area for min versus woman by regrouping this and finding averages, etc. So it does that for each of the parameters. And then at the very end, up into and including failure load, of course, if you don't have some of these results, like failure load, just don't enter them and you won't get percentile results. It's fine. But it also figures out that there is a person who's identified as bone 0066. They're given an automatic username, a very difficult to understand one. But that username nonetheless can be used along with the password to visualize this data. And so you should see this username here, 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 and here, here, because it's the same person at 6 different points. It's only one password to be able to log in. So let's take an example here and using that username and password. And we now go back to the normative site, and instead of going through the researcher portal, we go through the patient portal and we enter the username and password for that person. And it brings up this. So somebody can be at home and say, oh, I was participating in that study in Calgary. I logged in to see my data. If you click on scan 1, scan 2, scan 3, 4, 5, 6, these are each of the individual scans. And like I showed before, it kind of represents it in terms of colors. And this can be interesting, for example, if you wanted to limit what's shown in these reports, then don't run normative with every single parameter ticked in that tick box. Just run it for, say, total BMD or something like that, and that'll give somebody useful information already. So it's a way to remotely, you can either have people remotely log in to see their data, or you could mail them a copy of the PDF that I showed you earlier. So I'm just going to finish off here by saying some acknowledgements to people who have been working on this. So Saeed Jaffrey is the great student who did fantastic work building the structure of this website. Lauren has been very involved in all of our normative data in the lab, and from the first generation all the way through to our second generation, and Danielle as well, especially well for the second generation data, and as well working on bugs and so on within the normative website. And so I will end it there. I welcome you to go check out bonelab.ucalgary.ca, and of course to go check out the normative site. But what I'm going to quickly show you is an example of actually running the site. So let's go. And we're going to go into the researcher portal. Steve. And then I'm ready now to drag and drop. But what I'm actually going to do is I'm going to try this out, the converter. So you can't see this because it's off the screen, but I'm looking for the file that has the original UPAT list, and I'm going to drag and drop it onto here, and you can now see it's read the file, and it already created a download. So now I'm going to click download. Then I can open that file, and you can see it actually worked really nicely. It put quotes around the names, that's fine. It identified the scan numbers, etc. I should open this with Excel so I could see this more easily. And it shows all the different parameters that were in that original file. It doesn't have failure load because that wasn't in that file, so you can manually add that on as the last column to your data. So once you have that file, then what you would do is you go back to the normative website, and you would go back to my dashboard. You would find that file here, and I'm going to drop this. I'm going to drop the file onto the site, and you can see right away it asks which of the data types I want. I choose Extreme CT2. It's reading the file. It found all of these headers. I'm going to select them all, but let's just for fun, let's not do them all here. Let's do all the BMDs, 3 BMDs, okay? And then once I'm happy with that, I click go. Would you like PDF reports? You know, if you're never going to share this with your participants in your study, then click no, but it doesn't hurt to click yes. That way you'll have them. And now we have to wait. There we go. So it's downloaded, it's finished downloading. So I click on download. And it's going to grab a zip file. Then I can open that zip file just like I showed you before. And in that file, we don't have as many of these plots anymore because we only had cortical BMD, intravehicular, and total BMD, but I can quickly look at these. Then I can see the patient reports, and I can see the README that I was talking about, and finally the researcher report. So let me open that. Here's the researcher report, and it's way too many decimal precision here, but shows the percentile and Z-scores as a function, and at the end it shows you the usernames, and it doesn't give the passwords again, you'll notice here, because we've already entered these people into the database once, and so they don't get a new password every time. So there will be more scans assigned to that person now. And with that, I think I should close. I think that's everything I can show you about normative, and really appreciate your interest, and feel free to shoot me a question. My email, which I should have written on here, is skboyd@ucalgary.ca. Steve Boyd. Cheers.